All right, so I see a lot of names, new names, so welcome everybody. Thanks for coming. We're going to talk a little bit about using HEC-RAS and Civil 3D, mostly just to take data back and forth. I'm not going to get into the analysis stuff for HEC-RAS. It's really not most CAD tech's thing. They should only really know how to get it for the engineer so the engineer can do the work. I'm going to share my screen so we can just look through everything as I go. Let's see. So, can everyone see this? My screen should show QGIS with a parcel on it. Good. All right. So, project that I picked for this is this little somewhat triangular shape. We have 4 DEM squares that I pulled from Tenrez. You can kind of see that it generally drains. There's a creek or something over this way. And most people, when you go looking for data to bring into Civil 3D, you're going to probably ignore the DEM data just because Civil 3D doesn't really want to bring it in. Like if I were to come in here and go to the surfaces to create a surface DEM, you only really have these options, a DEM file or GeoTIFF or these other binary Esri stuff. And that's not really what they give us from Tenrez. If I switch over to the folder that I downloaded it from, they gave us image files. They don't really work for us. Like we could find that in here. Where did I put that? So if I were to look in here and just type star, we can see the image files. We can even pick the image file. It just won't read it. So it's kind of useless to us directly in Civil 3D. So that really leaves us with the option, the alternative option of using the shape files they provide us for the contour lines. And we all know that if we download that, we end up with 2 foot or 5 foot. We usually want to keep our 2 foot contour lines. Then we end up with all of these files that are just taking up space that we have to then weed through and figure out which ones are the ones we want, which I end up always coming into QGIS and kind of trying to figure out which tiles we have so that I can process them. It's kind of a pain in the butt because you could not process them and just bring them straight into Civil 3D, but then you're running the risk of having to build a giant surface and then clipping it yourself later. Let's see. Like in this case, I actually brought in 4 of the tiles, the same tiles of my area, and it builds them okay. But because they're contour lines, you're going to see a lot of issues. Like because they're 2 foot, you're missing stuff. It's going to interpolate between. You're going to see crap like that, or you're going to see missing stuff. So like over here, these lines, the surface is the actual survey. So you can see that it's missing some information just because it's 2 foot. It shows all kinds of stuff like this. You have crap like that. If you're okay with that, you can keep using it. I personally am not. I want to, especially if you're going to HEC-RAS and you're going to be doing some analysis, you want something a little cleaner than that. And that, I guess, would be okay for some people, depending on where you're analyzing. Like, if we're down here, it might be fine. Let's try and bring some of this stuff into HEC-RAS to see how that'll handle. So before we do that, let's actually no. We need to set up a project before we do any of that. So in HEC-RAS, you'll need to create a new project. Find your folder. Save over that. So thanks, Andy, for actually bringing my attention to this. I didn't realize HEC-RAS had these GIS tools that are actually really helpful. So anyone that doesn't know, in HEC-RAS you have this RAS mapper that is a really nice little GIS interface where you can bring in your shape files and all your other data. So in this case, I brought in my parcel so that I kind of know where I'm at. When I have the contour data and you bring that in, excuse me, let's turn that on. You can kind of see it a little better in this instance. Some of the issues that we saw over there, when you zoom in here, you have all these little chunky pieces. But when you're wanting to bring in to a HEC-RAS, you'll come over to the terrain section in your RAS mapper. Just right click and you'll select create a new RAS terrain. This little dialog box, you'll select all the files you need. There'll be raster images, of course, so you'll need TIFF files, FLTs, ADFs. So what I did earlier is I exported this contour file. Well, let me show you all how you do that. If you come over to your surfaces and just right click on the surface, come down to export to DEM. This dialog box lets you save it to a location. I'm gonna save it in here. Gives you a name already. I'm gonna actually do it at 10-foot intervals because I found 5 foot just took too long. Change it to 10. It's basically gonna just sample your surface at this intervals grid. Click OK, and it will just start writing it out to a file for you. Now, depending on the size of your file, this could take a while. This is this big square grid, so even 10 foot was probably too small of a grid. But I'm just going to let that run while I jump back over here. I'm going to select the 5-foot one that I made earlier. You'll want to give it a name because it just defaults to terrain, and if you were to need to make more than one, you're just going to end up overwriting it. So I'm going to call it contours 5-foot. And just create. It'll process it. It's really fast at processing most of the data. Click the close button, come back to RAS mapper, and it'll have it shown in here. And if you select that, just select it once, it'll say that you have it selected. You can just highlight over here anywhere, and your little cursor will give you elevations of it, which I found really nice for needing to just kind of take a look at things. But you'll notice that, again, you're just short on data. Like, there's a road that goes through here, and you can't really tell. Or in the Civil 3D side, we knew that there was some kind of cut going through here. You can't see that. All you can see is the interpolation between contour lines. It looks kind of like a rice farm. Really not the best quality thing. So what I would prefer to do is go back to that original DEM data that I downloaded from Tenrez, and if I have survey data, even integrate that. So what I've begun to do is just splice them all together here in HEC-RAS because it does that really well. It lets you use different grid size surfaces in order to do that. So come back into create terrain, select your terrain file. Let's say earlier I did my survey as a 1 foot DEM, and now I need to bring in that DEM data from Tenrez. Now, by default, this is looking for TIP files, FLTs, but you can actually change it to all forms of raster data. So you'll see these 4 image files that were in there from Tenrez. Select all 4 of them, hit open, and it'll list them underneath the one you've already added. Point here is you want to make sure these are in the order that you want them to appear once they've been built. So your survey being the more current data, you want it on top. So it'll be layered pretty much like this. We'll give it a name. DM and the survey. Click create, and it'll process all 5 of those surfaces and then do a nice little splicing at the end to merge them together. And again, it goes pretty quick. Final steps, almost done. Okay, so now we have this much nicer looking surface. If we zoom in, we can see all this little bumpiness that indicates that there's more data than every 2 feet in elevation. We can see this little pond here. We can see this pond over here, some little hillocks, stuff like that. We can even see kind of where our culverts are as they cross this road that is now very visible in the model. Because I've merged our survey surface in, you can even see the difference in quality between those 2. Turn that off, make it a little more apparent. This line right here would be the edge of our survey. And because I did 1 foot, you can kind of see the grid in that too. Any questions on that so far?
Can I interject?
Sure.
Something that Adam didn't point out, but I think is important, is that when you set up RAS Mapper for the first time, which he's already set it up, you're going to need to tell it a projection.
Yes.
And you can kind of show them that. I think that's important.
Yeah. So, yeah, I did make a note to mention that, and I just glossed right over that. So when you've opened RAS the first time in your project, come over to the Tools, pull down, and select the Set Projection for Project. This area will be blank, so you'll need to select a projection file from any of the shape files you've created for your project. In this case, I created that parcel file and used that. Because I think you were the one that actually pointed out, Andy, that there's a project file that gets created with HECRAS, and if you pick that, it's the wrong file.
Right. Yeah, the HECRAS project file is a .prj file, and an Esri projection file is also a .prj file, and don't confuse them. They are different things.
Yes. So if you don't see all this data that most GIS people will understand, then you've got the wrong file. As long as you have that, you should be fine to be able to project any data that you bring in to make sure it's all correlated and on the same coordinate system.
The other, go ahead.
My question was, when you're bringing in DEMs and survey data that, for example, have different projections, like anything we get from Tenrez is in UTM, is HECRAS projecting on the fly to that coordinate system you just set?
Yes. So all this DEM data that I brought in is what Tenrez had set it at on their metric UTM, and then my survey was on North Central Texas. So it did the conversion automatically for me because I had that set.
Courtney, on the back end, it's built on top of GDAL, the Geospatial Data Abstraction Library. So it's making the translations off of the GDAL, so it's intelligent enough to pick it up. The only thing that I've had a problem with is a lot of times the data that's downloaded from Tenrez, the vertical rasters might be in meters, and you just need to pay attention on the vertical rasters. You know, survey vertical raster from Civil 3D might be in feet, but the vertical rasters from Tenrez might be in meters. So you might need to do an intermediate surface just to make sure everything is to US survey vertical feet. So just pay attention to that.
Yes, I typically have to prepare this data for people that are doing HEC-RAS, and that's why I was asking for that especially as well.
Adam, can you import a surface? Don't import it, just show the import dialog. I just want Courtney to see that.
In here?
Yeah. At the bottom, you notice there's something that says vertical conversion. And that will say use the input file. So like if a UTM surface is coming from Tenrez, it's smart enough to know if that input file is in meters and your projection is in feet, it'll make the conversion for you, which is why Adam didn't have to go in there and specify it, but it's just something to pay attention to. So if you just bring in Tenrez and nothing else, sometimes it gets a little confused, but that's gotten better in the last couple of versions.
Yeah.
That's really good to know. Thank you.
Yeah, with this process, you don't have to do a lot of that converting that we would do on the Civil 3D side. Like, because the contours you get from Tenrez were not properly assigned their coordinate systems, sometimes it'll come in way off, or it'll come in meters instead of feet. Like all the elevation data in the shape files are assigned to meters. And Civil 3D doesn't handle that as well as this does.
I guess so. One more question / clarification. Every time I prep anything for somebody in HECRAS, it needs to be in grid, so that everything is in grid instead of surface coordinates. Are y'all on the same page there?
I am. I prefer everything to be on the same, and since the majority of all the data we use before the survey is on grid, I try to keep everything on grid so I don't have to deal with that conversion.
Courtney, it just depends on who your end user is. If you're doing a bunch of crap for TxDOT, then you're going to have to do it on surface coordinates. But if you're doing something for a FEMA submittal and your project is set up in grid coordinates, then yeah, do everything in grid coordinates. It just depends. If your end user is a GIS user, i.e. like FEMA or some kind of city reviewing entity, then it depends on your project. I don't think it matters. It just depends on what your end user wants you to do.
So once you have your surface in HECRAS the way you want it, you'll want it to match what you have in Civil 3D for your ultimate presentation of that data for your exhibits or whatnot. You can then take this surface and export it back out to another GeoTIFF file that Civil 3D then can use. So if you were to just right click on your terrain, come down to export layer, you can resample the entire thing to a single GeoTIFF file. You can then actually tell it another grid size you want to use, 5 feet, 10 feet, depends on the size of your data. Give it a file name, input, and then just hit OK. And that was a really fast export. I did 5 feet and it was not much slower than that. So this being this big of an area, this still goes really fast on the HECRAS side. And then come back over to your Civil 3D, create yourself a new file to bring that into. You can go to your surfaces, create surface from DEM, and just pick your geotip file. It'll do its little 4-step build down here. Zoom extents, and then you have your surface. So pretty easy. It's when you check your tool space, you'll see that it's a grid surface, so you won't be able to do any of the normal editing you would if it were a tin, but you can just insert that into a tin file and you'll still be able to do all the same processes. If it's too large of an area, you can always just create a little rectangle and give it a data clip. Guess I missed it. And then move your data clip up in the definition so that it actually gets clipped properly. And then wait on it to process. There you go. That'll make your file just that much smaller if you don't really need all that extra data. Right. Any questions about that before I move on? Okay. So let's see. Say in this project we were doing just a small little analysis. We drew in our center line and we drew in our cross sections where we thought they would be. We want to take those to HEC-RAS now. A few things that you want to be aware of so that your engineer doesn't have to deal with this later is your stream needs to be drawn from the low point to the high point. So the best way to check that, use the pedit command, edit the first vertex, and you can see the little glyph down here, maybe difficult to see on my screen. And then all your cross sections need to be drawn left to right, looking downstream. I still think it's kind of stupid, but I get that they're using methodology from when people still ran boats down the river to do this work. So also check those, use polyedit, make sure your first vertex is on the left side of the stream as you're looking toward the downstream end. Use your map export to export all these to shapefiles. Map export. So say my stream, I'm gonna just overwrite what I have. If you want to do it as a line, select your object and just click OK, export it out. Do the same thing for your cross sections, and then you can come back over to HEC-RAS. And if you've already got a geometry file created, you can add them directly to that. If you don't already have a geometry file, in the main dialog for HEC-RAS, click the little View Edit Geometric Data button, come over to File and click New Geometry Data, and give it a title and file name. So I already have one created, so I'm just going to keep this one. Let me open that so it's just attached to this. Or not, just right over it. Okay. Coming back to the RAS mapper, once we have a geometry data file, it'll be listed here under geometries. Right now, it'll have nothing in it because it's brand new, blank. If you right-click on the geometry that the name of it, you get this menu that has edit geometry in it. Just take note that it's still in beta. I haven't really had too many problems with it, but it is still beta, so if you have problems, you're on your own. Once you select beta, you can then right-click on river, come down to layer properties, and then go to the features tab, and you can import features down here. You can select your stream centerline, and oh, there it is. As soon as it lists it here, it'll show up here in a background here. You can see this blue line, that's the center line of my stream. Just close this dialog box, come down to cross sections, right click, layer properties, features, import features, and then select your cross sections. And it'll bring them in the order that they were in there, but they'll assign them the correct river station based on the center line of this. Hit the X, come back over here, right click, go and select stop editing. It'll ask you if you want to save, and it'll just rewrite all that back to your geometry file. So when you come back into the main HEC-RAS window and click the edit geometry, it should have shown up. That's odd. Any reason for that you can think of, Andy? Why it wouldn't have shown up here now?
That happens sometimes. RAS can be a little finicky about it. If you create a flow file and a plan file, it should reconcile. You'll need a flow file first if you're going to try to run it.
Windows.
Yeah, that's RAS. You're gonna try to run it? Yeah. So right there, it's not even picking it up.
Okay.
Close RAS entirely and get back into that project. I bet it comes back in. Still not.
That is weird because it worked perfectly fine earlier.
That's all right.
That's okay. For our purposes, we don't really need to be in this one anyway. We're all about working in here.
Oh, it looks like you've got two proposed now. That's interesting.
That is. Well, let me delete this one and just redo it to that one. It goes so quick in this that it doesn't really matter most of the time. Right. So coming back, just double checking. Oh, yeah. Make sure you save this when you're done. It won't let you open the geometry while it's opening for editing in here. So now we have it visible. Okay. Excuse me. One of the other cool things that I've actually had to use on this is because we can edit it in here, come back to the edit geometry, we can directly edit all these features like we would in any other program. Select so we can draw in a new cross section, or we can edit this or split it. We can delete it. I've had to add in points to a few of these. Yeah. It's always a little finicky though. I want to select that, and I want to just, didn't want to make it separate. Trying to get to the points.
You're on a create tool. You need to be on the edit tool.
Oh yeah. Okay. There we go. So if we need to move these around, we can just manipulate them, whatever we need to do. And then just reclose or stop editing to resave that back. I just realized this morning that that's not the only stuff you can edit. Like I brought in this shapefile for just reference, but I found that you can edit that too and make those same changes to the shapefile you brought in.
Now, does that actually edit the shapefile where it was originally saved, or only in this where you can export it back out?
No, it edits it in the original shapefile because this is, yeah, it's just referencing that shapefile directly.
Okay. I
Yeah,
don't know.
so if you're going to edit it in here, you want to be wary of what file, what you're referencing for your layers in here. Like everything in the geometry up here, these aren't referencing the shapefile. These are in the RAS geometry file. Any of the map layers, those are the shapefiles. Oh, speaking of the map layers, we can bring in a lot of additional web layers, which I've found pretty useful too. We have all this imagery that we can pick from. A lot of the time, the Bing maps that we have in Civil 3D just not that great. We use the Google satellite map. Just select that and click OK. It'll add it in there, and it brings it in right where we are. We can even adjust its display properties so that we could make it a little more transparent, so that we can still see our terrain behind it. This is a great feature if you want to use these images as well. So if you want to use that Google image in your plans, you can come in here, pick the area you want to see, right click on this, come down to export layer, and just export it to a TIFF. So I'll put it here, aerial. And then we can come back to Civil 3D and bring that in using the map insert file or command. So, there we go. Now you have your choice of imagery, and not instead of just using the Bing maps that Civil 3D provides, which is much nicer. These are usually a lot crisper. You can even get them a little more by zooming in first, but you still only have the limits of your view that you're saving out. So you have to keep that in mind too, depending on how much you want to see. And so now, once your engineer has done their work in HEC-RAS, they've modified these cross sections, made changes, created their analysis, you need to get it back to Civil 3D for display. Like I made that one change. So we come back into RAS Mapper and we can right click on our layer that we want to export, come down to export layer and save that back to a shapefile. Select where we want to put it. Come back into Civil 3D, and now we can use just our map import command to bring that back in for us to use here. So update that, bring that in, and it'll draw in all our new lines. So this is the one I changed. We can see that it differs, and then we can just replace it with that one. If you've already imported them once, just be wary it's importing all of them. So I now have 2 lines right here. My original cross section that I exported earlier and my new one from that model. Okay, any questions about that? All right. That's really all I had about exporting between HEC-RAS and Civil 3D. Is there anything else anyone would like to see, hear about through these workflows? Or did I miss anything that y'all think is important?
I was still getting my lunch when you did the export the DEM. So you basically bring in the topo from the city, and then you create a surface based on the topo and then export it as a DEM, and then it can import it into RAS Mapper. Is that what
Well,
you did?
you can do that. What I did ultimately was just use the DEM from Tenrez.
Okay. Have you
Yeah.
worked with the flood plain analysis in AutoCAD?
I have, and honestly, it is a pain in the butt if it works.
Yeah, I've been dealing with the Brushy Creek stuff, and it crashes if I try and reopen the file.
Yeah, like I've had every time I make something in it, I essentially have to start over because I make a model, save it, close it, reopen it, and it won't open.
Yeah, it crashes immediately.
Yep.
And it's also not approved by most cities for their floodplain modeling, right?
It is HEC-RAS.
Yeah, it's the same engine. I don't know, but I can't get it to work nearly as efficiently as HECRAS.
You said that is through Civil 3D?
Yes, it's the river analysis tools.
Okay.
And Courtney, I'd strongly recommend against using those river analysis tools. Autodesk bought a company, acquired that software, hired a guy to foster and manage it, and that guy no longer works for Autodesk anymore, and it's become a little bit of a bastard piece of software, to be honest. It's unstable. That's what Adam's running into. And anybody that I've ever talked to that's kind of asked which way you're going to do it, I would recommend the way Adam showed it every time. You need to be doing your work inside of HECRAS if you can. The actual simulation and analysis. Civil 3D is where you're going to do your work maps. You're going to produce your exhibits. You're going to create line work to use on your construction plans, and RAS is going to export those type of flood boundaries and even velocity grids. I mean, it can give you all kinds of stuff, but in the end, you're going to either dump that back into a GIS or CAD program. And for this presentation, we're talking more CAD sides, but that's kind of my recommendation. I would not get into the river analysis software at all.
So if I have a on-the-ground survey and I need to use that for my HEC-RAS through the property,
Right.
but then I've got the rest of the site I need to use the GIS LiDAR stuff. Is there any way to merge that and export that the way you
That,
did it?
that's exactly what Adam just showed.
Okay, I need to.
He had a surveyed site that he pasted into the surrounding Tenrez 3-meter GIS. Actually, that's bare earth LiDAR data that he pasted it into. So you let RAS do the compositing. You don't do that compositing inside of Civil 3D. And I would recommend, David, just engineer to engineer. Hydraulic analysis, the rule of thumb is you need a 3-foot resolution DEM to do the analysis.
Right.
So, the minimum. So if you're pasting data from Tenrez, go ahead and use their native resolution at 1 meter, which is about 3 feet. And that's going to be good enough for hydraulic analysis.
And is that better than using on the ground topo?
No, on the ground's always going to
Okay.
win.
Yeah, that's what I thought.
Yeah, assuming your surface is done well, you're going to paste the on the ground on top of the 1 meter, but the on the ground's going to win where you have it.
And then you take your combined surface and export that as a DEM so that you can bring it into
No, sir.
RAS.
No, you export your survey, your field survey. You'll export at whatever resolution you want to live with. I've done 1 foots before. You can do 2 foot or 3 foot DEM resolution. You'll export your survey as a DEM, as its own separate DEM surface. And then you'll go into HECRAS and you'll let HECRAS do the compositing with the downloaded GIS data. And you'll paste, just like you do in Civil 3D, HECRAS will allow you to paste surfaces in the order that you want them to be pasted. And
Okay, because I see on here he's got DEM plus survey. Is that?
Right.
I guess I'm gonna have to watch it over again.
Yeah.
Let me show you real quick. So from the terrain, create a new RAS surface, select your surfaces. Exported from Civil 3D was my survey, and then come back.
Okay, I got you.
The DEMs from Tenrez. So it's 4 tiles for this project at least.
And
Go to
then
file
does it?
name. Click create. Now.
And what? And order?
Yeah, the
I guess
order that it's listed here is the order that they'll be pasted
layer wise.
layer wise. So the survey would be on the top.
Okay.
And so I often require to have our survey data for our projects, and then I utilize Tenrez data to have our contours outside of the project to fill in topo data for our, other purposes in Civil 3D. So I will export that surface that I created for our HEC-RAS team. And I guess if they needed more, they would go grab more Tenrez. But why do y'all not recommend using that pasted or already created existing ground survey and outside GIS data and then bringing it in?
So Courtney, when you're compositing your surface to export, so you're doing the work to composite the surface inside ArcGIS or something. When you take your survey data and composite it, are you specifying a specific spatial resolution, a DEM grid resolution?
So my method is a little bit different than what y'all are showing. I'm typically exporting a land XML and then changing that land XML into a float in GIS for our HEC-RAS team, or just providing them the land XML directly, and then they'll do the transformation in GIS prior to bringing it into HEC-RAS.
So you're doing a 10 composite?
I guess so.
Okay, which is fine. There's nothing wrong with that. My worry would.
What do you mean by 10 composite?
Well, because a land XML file is not actually a DEM, right? That's just a series of irregular network. That's a 10.
Okay.
And if you're pasting that 10 through like an ArcGIS program into an existing surface, it's possible that, it's going to pick that up kind of accurately because you're doing 10s and not DEMs. Now, HECRAS can only read DEMs. It doesn't give a crap about 10s. and it's just built that way. It doesn't have any idea. So in the end, you've got to have a DEM. It doesn't matter if you do it, Courtney, with your expertise, it probably doesn't matter if you process that on the front end and then just bring that into RAS as one aggregate surface. It doesn't really matter. I would tell you that, frequently what I'm doing is I'm doing an existing model, and then I'll have to come back and do a proposed model. So then I'll do grading inside of Civil 3D again, and I've got to paste that into the existing surface that was already built. So it's just a matter of managing your surfaces. I would recommend for most, especially those that aren't real familiar in ArcGIS, to go ahead and let RAS do the aggregation. It'll bring in multiple resolution DEMs, and it will stitch them and aggregate them and do the pyramid scaling kind of automatically, which is really a beautiful thing to somebody that doesn't really have a lot of experience in a GIS program.
Yeah,
So
I was actually going to ask about that pixel size, right? That grid size. Like, was it important for them to always match? And you just answered that. No, it doesn't matter.
No. What RAS is using is called a HDF5 file. It's a hierarchical data format file. It's a supercomputing format that they've aggregated and adopted. So when that surface is built inside of RAS, it does not care about seams and spatial resolutions. You can have 1 foot resolutions on your survey, and you can have 3 foot resolutions on your LiDAR data, and you can have 10 foot resolutions a little further out, and it doesn't care. It tries its dangest to seam them, and sometimes you do have seam stitching errors, but that's because of the data. That's what Adam's showing right now.
Yep.
It's not congruent.
And we'll see that in Civil 3D as well.
Yeah, no, that's normal. And I'm not super worried about that kind of stuff. I think back to David's heart of question is, yeah, assuming the survey's done right, survey should always win. But frequently you're going to need data a whole bunch of different other places, and the Tenrez stuff is great. Adam for speed was doing 5 foot and 10 foot, and I totally understand that. But I would say for kind of a legit submittal, I would not go any smaller or any bigger than the 1 meter. If you're going to cut hydraulic cross sections, for hydrology, yeah, you can go bigger. That's nothing wrong with that. But for hydraulic cross sections, I think you'd probably want to preserve that 1 meter resolution. It's a lot slower on something that Adam brought in, which is we don't have time to watch him process data for 20 minutes. So I get that. I totally understand that. But sorry, I'll shut up, Adam. I'm hijacking.
Oh no, that's quite all right. You're technically the expert in this.
I've had conversations with the guy that wrote this software. His name is Cam Ackerman. He works for HEC. There are some weird things that happen, and I want to point this out to the group. So let's say you do a floodplain delineation inside of RASMapper, and you get a DEM surface of water surface or velocity or whatever. When it exports, it'll create a DEM at the equal resolution of the underlying surface itself. So if, for example, Adam ran a hydraulic analysis on just this little reach, it would export a DEM that is gigantic. So it would be the entire surface that he's running the analysis on, which is irritating. So you'd have to do some GIS cleanup to trim it down and remove those nulls. Just a heads up, that was intended. The software was built to do that. I think it's kind of a bit of a fallacy, but it is something that I'm seeing. Courtney, you're asking where I'm working. I just retired from consulting world and kind of just doing my own thing now. So I'm really twiddling my thumbs trying to not keep my wife from going crazy.
May we all be that lucky to get to retire one day.
Actually, what I'm doing is I'm teaching a class at ACC. I'm doing a little bit of research with the University of Texas that actually kind of dovetails into what Adam was showing, and getting tugged on by the National Weather Service to do what they call base level engineering conversion to flood inundation mapping. So it's programmatic interaction with the stuff that Adam's showing. So I'm trying to do all this with Python code without actually touching RAS itself. Let RAS run in the background.
Andy, what are you teaching at ACC?
Abir is actually on the line. She's in my class. I'm doing the stormwater drafting for stormwater management.
Yeah, Andy is a great professor. He's my professor.
Wonderful.
Brown noser.
Oh man, no, I would have to agree with your expertise. You may want to talk with Sally Hall, who teaches GIS over there. It is her goal to make a HEC-RAS and GIS class, and I think you would be perfectly suited for that.
Oh yeah, that'd be right up my alley. And I think I've talked to Sally before. I really like her. Adam, I don't know if you can make me driver. There's something I wanted to show the group just because I've got a post that I need to finish in the next week or two, and I think this is germane to what we're talking about.
Yeah, real quick before we do that, I wanted to just point one more thing out that I wasn't able to show
Oh, there's your
using the data I
delineation.
had. So I opened the actual analysis for this project, and over here in our results, we have the inundation boundary, and we have the water surface elevation results layers. So all of these are generally stored as a shapefile in the project, the HECRAS project, except for the inundation boundary. So if someone needs that, they can go get it without having to open up HECRAS to export it. But if you need the inundation boundary, that's the only thing that has to be manually exported. Just to point that out for anyone that needs to bring that over to Civil 3D when they're ready to do their final presentation documents. And it's the same process. Right click. Oh, yeah, right click on it, come down to export, save to shapefile. Let's see. I'm going to stop sharing, Andy, and you should be able to just share
Yeah.
your screen
I'm going to
automatically.
try. Let me make sure I do this right. This is something I've been working on, but I really haven't released to anybody yet. But I think, Adam, you'll be super interested if I can get this to work. And I don't think I can demo what it's doing, but I can explain what it is doing. And it does work. We've tested it exhaustively. Let me make sure I do this right. Okay, how about that guy? Can you see a Internet Explorer window?
Yes.
Cool. So this is Jupyter, and I'm not going to get into the nitty gritty as to what Jupyter is, but Jupyter is kind of a web interface to run Python scripts. So this is me playing with Python to get certain things to work. I'm going to do a blog post in about, I don't know, a week or two, just when I can get to it. What this routine does is exactly what Adam is kind of doing manually. So the intent is you load in a shapefile, and it automatically, once that shapefile is loaded, it automatically goes to Tenrez's data, which is actually on an Amazon Web Service. It downloads everything that you need in the area that's requested, whether that's 1 tile or 500 tiles, downloads them, unzips them, merges them into one surface, and then clips and buffers it to the boundary of the requested area. So if you need an entire watershed, like you need Walnut Creek's watershed, or if you just need the site, it'll make that sample. So
Andy, what
go.
backend software are you using to do the merge and clip?
Rasterio,
Okay.
which is it's just an open source Python raster library, which is right here. There's Rasterio. So that's how it's done.
I don't think we're seeing what you're pointing to.
Oh, well, crap. How about now?
No,
Better?
we're still just seeing. Oh, yeah, there
Oh,
we go.
there it goes.
Sorry about that. I got 3 screens and it's a bit of a mess. Yeah, Rasterio, which is open source, and that's a Python library for merging raster data. So you load in your boundary for your shapefile, and you just tell it where it's going to dump export data. It uses GeoPandas to reproject that shapefile on the fly. So there's no ArcGIS here. This is all open source. It intersects the shapefiles, figures out what tiles it needs to download. This is where the magic happens. So these are all the GUIDs that are stored on the Amazon Web Service for specific data sets. Like mostly ours is CapCogs, which is one of them. This is working for the entire state of Texas. And then it, don't ask. And then it builds the URLs. It does a web request to the Amazon Web Service, downloads them, gets the tiles, unzips them, and then merges them in, and then ultimately clips it, and then requests, and it sends one DEM out for all the tiles itself. So you don't have to get into QGIS to merge the tiles if you want to do that. where you don't have to manage multiple tiles, and you don't even have to figure out, Adam, you're nodding. You don't even have to figure out which tiles you need to download, right? Because the service will do that for you. So you just say, hey, I need this polygon, and it goes, cool, what's the shape file? You give it the shape file, and the shape file goes, oh, I'm in Central Texas State Plane, and it goes, okay, reproject that to Tenrez's statewide service, overlay it and intersect it, figure out the tiles that you need, download them, unzip them, merge them, and then barf it back as one DEM file, which is really silly that I've had to write this, but it's super helpful once you kind of get into the mode of what you're doing. I'll share this. This will be
Andy,
I can
posted
see
on
a huge
Go ahead.
use for that.
yeah, I see
You can see.
multiple applications for this. That a couple of things that I wanted to ask is, do you have to use HEC-RAS, or can it be easily rewritten to use another program? And then two,
Oh, no. This is all Python. There's no HECRAS here. This is all just
Oh.
Python code.
okay,
Open
cool.
source Python code. Yep.
And then I can just add a print function for it to have shown me which tiles it did end up choosing.
No, it will. That's already in there. It's just I haven't run it. So this is Jupyter, which is just a Python interface tool, but there's some output functions that, let me see if I can find one.
I've seen
I don't
some
remember where it
prints.
is. I know
I've seen some prints in there.
it will do it. Well, it's not even a print. It's just showing a graphic, which is why I'm using, I don't want to get into the nitty gritty of this, but it's why I'm using, I don't even remember which one it is anymore. I don't remember. It's Matplot library, the Matplot library. That's just to create a little picture of what you downloaded as it's downloading. And then it will show you in the end what you actually got. I have to run it to get it to work, and I don't want everybody to suffer through that. But I'm working on a blog post, Adam. I'll post it. Once I post it, I'll send you a link directly, Adam, and if you can send that out to the group. It's going to be a little trying for the uninitiated because you'll have to set up your own Anaconda environment to get it to run. That's a little bit more than some people are probably used to doing, but probably someone on this group can figure it out pretty easy, and then you just let it go to town. So anyway, that's it. I'll stop sharing.
Yeah. Thanks. I can see some huge benefit to that. I've already got wheels turning on how we can merge something on top of that to give us a better interface that we don't have to do anything extra on. But
Yeah,
it's just on
you
my
want to compile it. You want to take it and compile it and build an interface for it. I'm more than happy for you to do that.
Okay, yeah, because I was totally thinking something inside Civil 3D, draw my polyline, click a button, pick the polyline, and it push out to that and do it.
Yeah, you could. That's very doable.
Okay. Thanks for sharing. I'm going to stop recording now, though.